Hello everyone and welcome back to the channel. Have you ever wondered how farmers and researchers can measure plant growth and crop health in real time without damaging the plants? Today we are going to explore an exciting smart agriculture technology called In-Situ Assessment of Leaf Area Index or LAI using IoT-based agricultural system. In this video, we will understand what Leaf Area Index or LAI actually means, why it is important for monitoring crop productivity, and how IoT sensors and smart devices help farmers collect accurate field data automatically. We will also look at the architecture, like the sensors use data transmission through the IoT networks and how this technology supports precision agriculture, water management, and sustainable farming. So if you are interested in agricultural IoT, smart farming, wireless sensor networks, or modern agricultural technologies, this video is perfect for you. Before we begin, please don't forget to like, share, and subscribe to the channel for more videos on IoT, AI, agriculture technology, and engineering innovations. Now let's get started. Here in this image you can see the IoT-based agricultural system for in-situ assessment of leaf area index, which is an important parameter used to evaluate the crop growth and canopy density. The LAI represents here, this LAI, it represents the total leaf area per unit ground area and helps determine how much sunlight is intercepted by plant leaves. So in the field, like you have various kinds of types of sensors such as the light sensor, temperature and humidity sensor, and soil moisture sensor, which are connected to an IoT node, and the IoT node collects the environment data directly from the crop field. And the sunlight falls on the crop canopy, where part of the light is reflected by the leaves and part of the light it passes through the canopy, and by measuring incoming reflected and transmitted light, the system estimates the leaf area index. Now the collected data, it is transmitted wirelessly to an IoT cloud platform for storage and processing, and here advanced algorithms will analyze the sensor reading and calculate the LAI value. The results are displayed on the dashboard, which shows the LAI here. Then it shows the temperature, humidity, soil moisture, and crop growth trends. Now a farmer can access this information by using a tablet or smartphone for real-time monitoring and decision making. So this will enable better irrigation management, crop health assessment, and yield prediction. So overall, the system demonstrates how IoT technology can support farming by providing accurate, continuous, and automated crop monitoring directly in the field. So here you can see the definition of the LAI, and here this is the working. Now next we'll see the architecture of the in-situ. So here this complete image, it shows or illustrates the system architecture of an IoT-based agricultural system for leaf area index assessment, and this architecture integrates the hardware and the software components to collect, transmit, process, and analyze agricultural data in real time. Now at the field level, here you have the agricultural area, it is divided into two clusters, that is the cluster 1 and the cluster 2. Now each cluster contains multiple wireless sensor nodes connected to a cluster head. So both the field areas are having the cluster heads, and the system uses two types of sensors, that is the ground level sensor, which is represented by G, which is installed within the crop canopy in order to measure the light intensity reaching the lower parts of the plants, and second is the reference sensor, which is represented by capital R, positioned above the crop canopy to measure the incoming solar radiation. So the data collected by these sensors is transmitted to a cluster head, and this cluster head, it acts as a local coordinator. The cluster head gathers the sensor readings from all the sensor nodes within the cluster and it forwards them to a central gateway. Now this gateway, it serves as an intermediate communication device which will aggregate the data from different clusters. It then sends the information collected through the internet to the MQTT broker. MQTT is message queuing telemetry transport, which is a lightweight communication protocol which is widely used in IoT applications because of its low bandwidth and power requirements. Now this MQTT broker, it forwards the data to the IoT infrastructure, which consists of the servers, databases and data processing modules. Here the sensor data is stored, analyzed and it is used to estimate the leaf area index. Now by comparing the light measurements from the ground level and the reference sensors, the system can determine the density and growth condition of the crop canopy. Finally, the processed information is made available to the user through a computer or a mobile device, and the farmers and researchers can monitor the crop conditions remotely, track plant growth and make informed decisions regarding the irrigation, fertilization and the crop management. So here you can see there are two types of sensors, that is the ground level sensor and the reference sensor. Ground level sensor, it measures the light within the crop canopy, and reference sensor, it measures the light above the crop canopy. You are having a cluster head which collects the data from the sensors and it will send it to the gateway. Then the gateway, it will aggregate data from clusters and sends to the MQTT broker. Then the MQTT broker here, it manages the data communication between devices and the server. So here this overall architecture provides an efficient, scalable and real-time solution for smart agricultural monitoring and the LAI assessment. Next you have this image, it is showing an IoT-based agricultural system which is designed for leaf area index assessment using the wireless sensor nodes, networks and the cloud-based monitoring. So the primary objective of this system, it is to measure photosynthetically active radiation, that is the PAR, which is the portion of the sunlight used by the plants for photosynthesis and growth. Now in the crop field, as you know that two types of sensors are deployed, that is the you have reference sensor and you have the ground level sensor. The reference sensor, it is placed above the crop canopy and it acts as a cluster head. Okay, here cluster head, it is placed above the crop canopy. Now next is multiple ground level sensors, that is which are represented by this G. Okay, these are placed below the canopy to measure the amount of light that penetrates through the leaves and the distance between the R sensor, that is the reference sensor, and the G sensors, that is the ground level sensors, it is maintained optimally in order to ensure accurate measurements. Now the sensors, these are connected in a star topology. Okay, so here these are connected with a star topology where all the G sensors, these will connect directly with the R sensors. Since the R sensors serves as the cluster head here and performs an additional communication task, it is powered by the solar panel, ensuring the continuous operation in the field. Now this cluster head, it will collect data from all the ground level sensors and it transmits it to a central base station, that is the gateway, and this gateway, it acts as an intermediary device that gathers the information from the field and forwards it to the IoT infrastructure through the internet. Now the IoT infrastructure, it consists of the cloud servers, then databases, analytics modules and the application services. So here the collected sensor data, it is stored, processed and analyzed to estimate the leaf area index and other crop related parameters. So the processed information is then made available to the user or the farmers and the researchers through web or the mobile application. So the user can remotely monitor the crop growth, canopy conditions and environmental parameters in the real time. And this architecture, it enables efficient crop management, better decision making, reduced manual effort and improved agricultural productivity through the smart farming technologies. So here you can see what are the reference sensors, or these are also the cluster heads which are placed above the canopy, and ground level sensors which are placed below the canopy. You have a central base station. You have an IoT infrastructure. So this is about the architecture. Thank you.